Hey you, how are you doing today? So today we are going to talk about the SD module. It works for SD cards formatted into FAT 16 or 32, and they can be up to 32 gigabytes, at least this model I have. And you feed it either 5 volts or 3.3 depending on your manufacturer. Why I bought it? Because I wanted to store the data from an Arduino project into an SD card so that I had CSV files with data. So this was my use case. I think it's always nice to know how devices communicate and which communication protocol they use. And in the case of the SD module, it uses a SPI communication protocol. So that's how it talks to Arduino. And the SPI is a 4-wire protocol where you have the chip select, the SCK or the clock, MOSI and MISO. MOSI means master out, slave in. So it's the communication from the master, from the Arduino to the slave or the peripheral, in this case the SD module. And MISO is master in, slave out, so it's a communication out of the SD card into Arduino. So now we are going to include 2 libraries which are native to Arduino to be able to work with the SD module. The first one is the SPI library, so it allows us to work with the SPI protocol. And the second one is the SD library, which allows us to work with the SD module. And you can choose a different digital pin to work with the chip select, but we are going to use the digital pin number 10. And I'm also going to declare a variable to store the file name so I don't have to keep doing it manually throughout the code every time I use it. I'm adding a little delay here because otherwise it might error when it tries to start the serial monitor and write into the CSV file at the same time. So now we just do some checks to see if the SD module initializes. And if it doesn't initialize, then we just print something to the serial monitor and we exit the code. So if we didn't exit the code, that means success. So let's just print this to the serial monitor. And now the type of data that we want to save in this case to the CSV file is data about temperature. So we want a timestamp and the temperature. So for that reason, we're going to create a header where we just write timestamp and temperature. In your case, you gotta think, why are you going to use the SD module for? So for our example here, we are working with the timestamp and the temperature. So basically, we are going to use the sdopen function to create our data file and check if the data file has been successfully created. And if so, then we're basically going to print stuff to this file. In this case, this header with the timestamp and the temperature. And then we close the file and we print something to the serial monitor just to indicate that this piece of the operation went right. And then in the loop, so this is it for the setup, right? We just initialize everything and we make sure we have a header. This is gonna run once, but we continuously want to check on, in this case, on the temperature and keep logging it to the file. So basically inside the loop, we're gonna access the data file yet again and check if it's there. And in case it's there, we're gonna print the timestamp, whatever it is, and the temperature, right? So in this case, we're just adding some bogus data, but in reality, and I'm gonna show this in a future video, we actually have real data about the timestamp, which is coming from a real-time clock. And we have the temperature data, which is coming from the DS18B20 temperature sensor. So in this case, we will not be using hard-coded stuff, but actual real data. And we're gonna be printing it continuously within a certain interval that we determine here under the delay. So I'm just choosing randomly 5 seconds, but of course, in the real scenario, you're gonna be using other amount of time. So let's start. Oh no, bug alarm, bug, something went wrong. So let's check my file, and there you go, it worked. So thanks for watching and see you in the next video.